Hi, today we'll be talking about the least squares regression line, or the LSRL. Okay, now normally I would seriously try to look up all of the formulas for putting in the correct symbols for everything. So basically I want to talk today a little bit about the y-hat. Now it's a Y with a little hat on it. It's like a pyramid hat. Okay, and for some reason it's just not typing into the black board I'm using, or the whiteboard. Okay, so we're just going to call it y hat. Now y hat equals a plus bx. Now you're probably sitting there going, you know what, that looks a lot like slope-intercept. Well, it is. This is the y-intercept. Okay, and then this would be the slope of our line. Okay. All right, and b is actually found by using this formula, so that's the slope formula, and then a is found by y bar minus b times x bar. Okay, enough about that. Let's actually take a look at how this works. Okay, so a line of, it's also called a best fit line, but it's a least squares regression line as well. Okay, here is PhET. This is the University of Colorado's physics education teaching tools, and they have a lot of great stuff for math too. And so right here we have the actual scatter plot. So we're going to make our own. So let's say that we actually make our own. So we actually drag out some points. This would be our scatter point type stuff. Okay, now let's say we actually calculate our line of best fit. So we go right here and we click it, and boom, there's my line of best fit. Okay, now we could also do residuals. You'll learn a little bit more about residuals, but residuals are just the differences between the lines. And as you can see, this is a pretty darn good line of best fit. Okay, now if I move around some of the points, look at how the line moves. Okay, as you can see, if I move one point up a lot, it only changes the line a little bit. So it doesn't drastically affect it. However, if I move two lines up, or the outermost lines up, that affects it. So it's actually really kind of cool how it works. Okay. And what you can do with PhET that I really like is that you can add a whole bunch of points and affect the actual graph. Okay? All right. Now, for example, if we accidentally started doing some actual points, as you can see, if I take off the line of best fit, this doesn't look like this has any kind of correlation, but once I put in the line of best fit, voila, there's an actual line of best fit. It's actually kind of cool. Now the other cool thing is that the best fit line, it will actually calculate it for you. Now it gives it in the form of bx plus a, but you know, it's still the same thing that you could do. Okay. All right. And the correlation coefficient. Now what you could see is that the correlation coefficient isn't very good. It's a positive 0.3, but that probably doesn't mean a whole lot. So the closer I move them to being along the same line, the closer the correlation coefficient fits. So as you can see, the closer they get to the actual line of it, the higher the correlation coefficient goes. Now the equation doesn't change much. Well, it kind of does, but the residuals change a little bit, and thusly affecting the correlation coefficient. Okay. All right. So what I strongly recommend is for you guys to be able to go out there and calculate and just work on everything and just be able to, and you can actually add a grid point so you can actually work with it. I would strongly recommend use a calculator to get the LSRLs for the best information you can possible and actually do it. Now another calculator that really helps is GeoGebra. Let me show you that. Okay, so you go to GeoGebra. Now you might have to add it as a Chrome app, or you might have to go .chromeapp or .org. Okay, what you do is you go to spreadsheet right here, and then you actually input your data. Okay, and so once again you're going to need, it's going to be a bivariate type of data. So let's say 14, 7, 12, 14, 12, 9, 14, 8, 11, 10, All right, so we just work with it that way. All right, now what I go up here is I click up here. Here, you're going to have to see it. Okay, I'm going to click up here. I'm going to drag this down so you can actually see it too. All right, I click on two variable regression analysis. Okay, so what I'm going to need to do is highlight all of the data. And you can actually see it scatter plotted over here, which is very nice because as you can see, it's probably going to be a negative linear regression. It's going to be a negative slope right there, and then you just pick the line of best fit, and voila, you have your LSRL here as well. Okay. All right. Now it doesn't give you R exactly, so you might need to go find a different model for that. But the really cool thing is it pretty much does everything that you need for an LSRL. Okay. All right. Now the formula is really complicated to work with, but the really cool thing is that you can actually find a lot of stuff for that too. Okay. All right. That's it for LSRLs. I'll talk to you later. Bye.